Welcome back. In the last lecture, we've executed a discover flooding attack on the DHCP server, which is also the default gateway of the LAN. Now, I'll show you a starvation attack, which can have far more impact on the network and its users. This time, the attacker will not flood the DHCP server with hundreds of discover requests per second, but he will instead send the discover request packets at a slower rate, allowing the DHCP to properly handle them. He will keep track of sent discover messages and wait for the matching offer replies. Finally, the hacker will send request messages in reaction to the received offers, confirming the IP list. In just a few seconds, all available IP addresses will be listed, meaning that there will be no available IPs anymore to send to newly connected devices, preventing them from accessing the network. It's the classical definition of a denial of service attack. Okay, let's go to work. To launch the attack, I'm gonna use another tool called DHCPig. It has a good implementation of this attack, and there are tons of available options. DHCPig is written in Python, has been tested on multiple Linux distributions and multiple DHCP servers, and uses the SCPy library. Even though it has a lot of options, to start a basic starvation attack, no configuration is necessary. Just pass the interface as a parameter to the DHCPig command. I'm gonna use Linux Mint, but you can use any Linux distribution you wish, including Kali. You will use it in the same way. DHCPig is not installed, but it belongs to the standard repositories, so I'm gonna install it using apt. As root, I'm executing apt update && apt install DHCPig. Okay, it was successfully installed. I'm checking the machine's IP and then launching the attack, DHCPig and the interface. In this case, it's ENP0S3. And we notice how it's sending DHCP discover packets, waiting for the offer packets, and then completes the entire IP allocation process. If you want to go deeper, start Wireshark and see exactly what it sends and receives back from the server. Okay, done. DHCP pool exhausted. This is the DHCP server, which is also the router and the victim of the attack. Let's check the logs of the DHCP server. And we see here tons of requests received from DHCPig and acknowledgements sent back by the server. All IP configurations have been already offered. If a legitimate client boots up, it won't receive anything. DHCPig goes even further. Once there are no more free leases, it will try to disconnect all Windows machines by simulating IP addresses conflicts by sending gratuitous ARP packets. This results in the Windows machines dropping their current address to fetch a new one from the DHCP server, but at that time there are no more IP addresses available. Okay, that's all about DHCP starvation attack. To bring my network back into its normal parameters, I think I'm gonna restart the router.